Hi everyone, this is Naveen. Hope you're all enjoying the Machine Learning Foundations for Project Manager course. I have somehow survived the first part, and this is my recording around the assignment that we are supposed to do towards the end of the first part. So, yeah, one second. Yeah, so this is the just the data that was given to us. So I haven't made any changes. So we have like a lot of parameters around a combined cycle power plant that you can see, and PE is the output or the target variable in this assignment. And in terms of the steps I took and how I approached this assignment, I can show you that in the next tab. Yeah, so the model I chose was linear regression, because looking at the data, the target variable, which is our energy output, is a continuous variable. So I'm kind of taking the supervised learning approach by choosing linear regression. And I've chosen two models just to see if one fits better over the other. The first model has all the four features, which are these first four columns A to D, as E is the output variable. So I've taken all the four features as inputs for first model, and in the second model I've dropped one. So I'm just using a model with just the three features. And in terms of modeling, this is pretty standard. So 80% training set, 10% validation set, and 10% as a test set. And I chose the model evaluation to be RMSE, which is the root mean square error model, because this is pretty standard as well, and it does penalize the larger errors more than the mean absolute error, MAE. And so hopefully with this combined with R squared, would give us a good result, because R squared kind of it explains the variance better in the data. So I'm hoping that these two combined together would give us the variances, and we can take decisions pretty confidently. Um, yeah, so that's the kind of summary in terms of what I'm trying to do. And in terms of the steps, I took the data, loaded into Excel. Just did the basic cleaning and analyzing the data on Excel. We did the feature selection. So, the two models, one with four features and one with three. I selected the model, which was your linear regression, as I just mentioned. And in terms of model evaluation, I did the linear regression. So I did the linear regression on Excel as under data and analyze data. So that's how I kind of went about this. So let's look at the first model. This is the first model where we took all the four features. So this kind of spits out, the summary is given directly to us by the Excel. So you can see that the R square is about 92%, which is pretty good. And this is the second model. This is the second model with just three features, and here the R square drops to 80%. So if we look at the summary, so we have the first, we have just the data here copy pasted, so no changes made from two columns A to E. And then by using the first model and using all the coefficients that the model is giving us, I predicted the PE on model one. So we have the predicted PE here, and based on model 2, the PE is predicted here. And in terms of accuracy checks, as I mentioned before, I'm using the root mean squared error. So if you look at the average root mean square for model 1, it's close to 3.7 versus model 2, which is 8.6. So lower the root mean square, better the model. So clearly we can see that the model 1 kind of sits better in terms of predicting the PE outputs. So yeah, yeah. That, I mean, in summary, like the model one predicted the output, which is more closer to the actual value, um, and we used supervised learning technique, linear regression, and we're able to say with confidence that when we use R squared method as the means of model measurement, and RMSE, root mean square error, to evaluate the model. And by using the four features as opposed to just the three features, we are able to predict the PE output of this energy plant with good accuracy. So thanks, guys. I hope this was useful.